Here we go. We're going to finish section 11.1 with one final example dealing with a standard deck of cards. A deck of cards allows us lots of possibilities for probability, so it's commonly used. So I wanted to introduce it to you. So before we get to these probability problems, just wanted to put on the screen the deck of cards. Now, there's a picture like this in the section on page 640 of the book. So notice what we've got here. The deck of cards, there are 52 cards. It's divided half into black cards, half into red cards. And then there are the black cards and red cards are divided into suits. And so the top row here, these are the spades, are what these are called. And the next one, these are clubs. I don't know where these symbols got their meaning from. The first red row obviously is hearts. And then last but not least, we've got our diamonds. And so these are what is used for a lot of probability problems, and we're going to use it for the next 5. So going back, the first thing we're going to do is we're going to find the probability of getting an 8. Okay, so remember, probability, how do we calculate it? Probability is the number of outcomes that agree with our event. So notice here there are 4 8s that I have. And so I'm going to go back. That means I have 4 out of 52. And we always write our probabilities as reduced fractions. So 4 goes into 4 one time, and 4 goes into 52 13 times. So there is 1 chance out of 13 of getting an 8. Problem number 2 says, what's the probability that my card is not an 8? So there are 2 ways to approach this problem. The first way is we could go back to our deck of cards and we could count up all of the cards that are not an 8. And sometimes that is a great thing to do. Other times that takes more effort than simply noting the following property. The property I'm going to take advantage of is that the probability of an event happening plus the probability that event does not happen is equal to 1. Okay, so I have taken into account everything that can happen. Either an event happens or it doesn't happen, and that happens with 100% certainty. So in this case, I've got the probability of my event being an 8 plus the probability that I don't get an 8 is equal to 1. And the reason I mention this is we just figured out that the probability of getting an 8 is 1 chance out of 13. I'm just going to put a question mark here for not 8 because that's what we're looking for. And if you remember from your basic algebra, I can subtract 1 over 13 from both sides. And I get that my number that I'm looking for, my question mark, is 1 minus 1/13, or 12 over 13. Way I got that is 1, the number 1 is the same thing as 13 out of 13 minus the 1 out of 13. I know that fractions sometimes give us trouble. So the probability of not an 8 is 12 out of 13. So next problem, number 3, is the probability of getting a club. So I'm going to go back to my deck of cards, and I'm going to take a moment. I'm going to erase the circle. Whoops. I'm going to erase the circle that I've already got here. For some reason, my eraser is not working, so let's try this. Oh, here we go. Now my eraser's working. Sorry about that. So now I'm going to go back to my pen, make sure that it's on a good thickness. And so we are doing the probability of clubs. And so the clubs are this every card in this second row that I'm circling right now, and there are 13 of those. So I will go back, and so there are 13 clubs out of the 52 cards. And I can reduce that fraction because 13 goes into 52 4 times, and 13 goes into 13 once. So the probability of a club is 1/4 or 0.25 if you prefer to use a decimal. Problem number 4 says, what's the probability of a heart and a 5? Now the word and means both those things at the same time. So what I'm going to do is I'm going to go back here to my deck of cards, and I want to know how many cards are there that are both a heart and the number 5. And so when I look, here's my heart row is this is this third row down here. And the only card in the deck that has both is the 5 of hearts right there. It is the only one that is a heart and a 5. So that happens one time out of the 52, and that is a reduced fraction, and I'm done. And so the final problem here deals with the word or. What's the probability of an ace or a picture card? And so again, I go back to my deck of cards, and I need to know what the probability of an ace or a picture card is. So notice or means one or the other. We might remember that word from when we talked about sets way back at the beginning of the class. And so I have 4 aces. And I have all of these cards here on the other end are called picture cards or face cards, they're sometimes called. And so that is 16 cards total. So that is 16 out of the 52. And reducing that fraction, 4 goes into 16 4 times, and 4 goes into 52 13 times. So that is going to happen 4 times out of every 13 tries. So that is probability with your standard deck of cards. Good luck on your homework.